Hello, this is Mr. Brooks, and welcome to Lesson 1-9, Perimeters, Circumference, and Area. In this lesson, we're going to find the perimeter of rectangles and squares, and we're going to find the circumference of circles. And we're also going to find the areas of rectangles, squares, and circles. First, let's begin with perimeter and area of a square. The perimeter of a square, remember, perimeter is the distance around the outside of the figure. The perimeter of a square would be 4 times the length of each side of the square, or 4s. Area of a square is the length of one side times the length of another side, which would be side times side, or side squared. Now let's go over perimeter and area of a rectangle. Perimeter of a rectangle, again, perimeter is the distance around the outside of the figure, is simply 2 times the base plus 2 times the height. Area of the rectangle is base times height. Area is the number of square units inside the figure. Now let's talk about a circle. First, remember that the radius of the circle is the distance from the center to any point on the circle, and the diameter, it goes from one side through the center all the way to the other side of the circle. Circumference of the circle is basically the same as perimeter, but when you have the figure has a curved edge, it's called circumference. If it has a straight edge, it's called perimeter. So the circumference of a circle is the distance around the outside of the circle, which is found by the formula c equals pi times the diameter, or 2 pi times the radius. That's how to get the distance around the outside of the circle, called the circumference. The area of a circle is pi r squared, which is pi times the radius squared. That will tell you how many square units are inside the circle. Now let's look at example 1 in your book. You have a pool that's 15 feet by 20 feet, and you have a 3-foot walkway around the outside of your pool, 3-foot deck. How much fencing would you need if you wanted to put a fence all the way around your deck? Well, hopefully, you know, we're looking for the perimeter of the walkway. Perimeter equals 2 times the base plus 2 times the height. Or, another way to say that would be 2 times the length plus 2 times the width. This distance, hopefully you will see that this is 26. You got to add the 3 twice, so be careful about that. That's 26 feet, and then this would be 21 feet. 15 plus 3 plus 3, and you would plug those numbers in and get the perimeter of the pool to be 94. In example 2, you're asked to find the circumference of a circle with diameter 12. Circumference equals pi times the diameter. So if they ask you for the answer in terms of pi, you would just say it is 12 pi square units. In other words, 12 pi units. In other words, just leave a pi in your answer if they ask you for the answer in terms of pi. If they ask you to the nearest tenth, then you would plug in 12 times pi on your calculator, and it would come out to be 37.69912. But you would approximate it to be 37.7. Alright, this is the answer to the nearest tenth, and this is the exact circumference. Don't forget, if they ask it in terms of pi, leave a pi in your answer. Now in example 3, you're asked to find the perimeter of the triangle that's given. First, you could find the length of the bottom segment. You could find the length of all 3 sides just by using distance formula, but I hope you find an easier way to get the length of the bottom segment, the horizontal segment. All you would have to do is go from -1 to +5 and get the bottom segment to be 6. The vertical segment, all you have to do is from -2 to +6, so hopefully everybody will agree that is 8 units long. Now the tough part comes in getting the length of the blue, the diagonal segment, and that you would need to use the distance formula. Now when we plug in the coordinates for A and B into the distance formula, we're going to get the square root of the quantity of I'll start with my 6. Again, you can start with any of the 4 points. 6 minus a negative 2. Yeah, you start with the 6. You got to do your y's first, quantity squared, plus the quantity of 5 minus a negative 1, quantity squared. And that would be the square root of 8 squared plus 6 squared. So you get the square root of 64 plus 36, which equals the square root of 100, which equals 10. So this side is 10, the bottom is 6, and the right side is 8, giving you a perimeter of 24. Example 4 asks you for the area of a rectangle. Remember, area is length times width or base times height, but the key to this problem is that you have to have the same units. So the first thing you're going to have to do is change 27 yards, or 7 yards to 21 feet. There's 3 feet in a yard, and then you can easily figure out that the area of this rectangle is 84 square feet, which would be written like this. Example 5 deals with area of a circle. Remember, area of a circle is pi r squared. So the key to this problem is make sure you cut the diameter in half so that it has a radius of 5, and 5 is what you're going to plug into your formula. So it would be pi times 5 squared, which would be 25 pi, if they want the answer in terms of pi, 25 pi square inches, or you could plug it into your calculator to get it to the nearest tenth. Example 6 deals with finding the area of irregular shaped objects. And as the postulates on page 64 tell you, you find the area of irregular shaped objects by adding up the area of the non-overlapping parts. Yes, there is a much better picture of this figure in your book on page 64. The way you're going to do this is I would break it up into 3 rectangles. Here's one possible way. First, you're going to break it up, and this is a 2 by 6, so the area of this rectangle is 12. This one is a 2 by 4, so the area of this rectangle is 8, and this is 2 by 2, so the area of that. And then you add up the non-overlapping parts and get the area of this entire figure to be 24 square centimeters. This concludes Lesson 1-9.